Welcome to qnawire.
So in this problem, we're kind of redoing problem 50, but now we're saying that the stuff coming out of the condenser is super cooled, um, is subcooled, sorry, subcooled to by 10 degrees C. So we have before, if we looked at a saturated liquid water at 20 psi. We had the pressure or the temperature there was about 60 degrees Celsius. And now, because now we've superheated, subcooled it to 50. So we're down here at a slightly lower temperature now, coming out of the condenser. So that's the difference. Again, the isentropic efficiency of the turbine is 90%. Everything else is the same. The specific volume at 1 is slightly different now, and so the pump work is also slightly different now, which means that, and the enthalpy at 1 and at 2 are slightly different. Okay? I think I missed point 2, should be here. This is 5 and 6, and arrows for flow. All right. So then we can go through and we can look at everything down here. That is all exactly the same as before. Likewise, this is the same. This is all the same. This winds up being, let's see here, that winds up being slightly different because, let's see here, H2 is different. This value is different here. The rest of these are the same, I believe. Yeah. So this value is different. So now we have about 26% bleeding off as opposed to 24%. So the work in the turbine, just like before, but now with different values here, is 657.2 kilojoules per kilogram as opposed to 686.5. So we got a little less work out of the turbine because of this. And the heat transfer in is 2,353, which is exactly the same as before, because we wound up at point 3 here, the same enthalpy at 3 as we had in the previous problem, and the same enthalpy at 4. And so then the net work, again, is the work from the turbine minus that of the pump. So we did a little bit less work put a little bit less into the pump, but got quite a bit less out of the turbine. So this drops to 654.2 as opposed to 665.5. And so then the efficiency drops to 27.8% as opposed to 28.3%. So subcooling this is not good. We want to actually just keep it right here at the boundary so that we just have a saturated liquid going through the pump. So again, subcooling, not very good. Obviously, having from the previous problem, having a non-perfect, non-isentropic turbine is also hurts our efficiency, as we would expect. It's hard, it's not quite clear exactly why this is different. Why this is different here, other than, we can see that we have, H4 is the same, H5 is the same, H6 H6 is the same. So all of these enthalpies are the same. It's just Y that changed. And so that's why we got less, because H3 changed, so that changed Y, so that changed this. So it's really kind of H3 that that is the problem here. Is it H3 that changed? No, it's H2 that changed. So again, by having a lower enthalpy here, we have more bleed off here, which means that we have less less power out of the turbine. All right, yep, that makes sense. It's not very intuitive though that having subcooling this would affect things very much, but it does quite a bit actually by 10 degrees C. So we don't want to do that if we can avoid it.